There will be a city on Mars, not a base, not a research station, a city. And the plan to build it is already in motion. By 2050, if everything goes right, and a lot has to go right, humanity will have a second home. Not on Earth, not in orbit. On the surface of a planet 140 million miles away, where the air will kill you in seconds and the ground is literally poisonous. This isn't science fiction anymore. This is the actual roadmap. And it's weirder, more dangerous, and more creative than anything you've seen in a movie. Let's walk through it, step by step. Here's the thing most people miss when they imagine a Mars colony. It's not just about getting there. It's about staying there, forever, without help. Compare it to a moon base. The moon is only one day of travel from Earth. If something goes wrong up there, you call home. Supplies arrive fast. You could technically commute. Mars is nothing like that. One way, you're looking at 8 months in a tin can hurtling through deep space, even with advanced nuclear propulsion, which we don't have yet. The best case scenario is still around 45 days. You can't just call for a resupply run. That changes everything. A Mars colony cannot depend on Earth. Not for food, not for water, not for fuel, not for anything. The people who live there will have to take a dead, frozen, toxic planet and squeeze everything they need out of it. Every single necessity of human life, from the air you breathe to the food on your plate, has to come from Mars itself, eventually. That's not just a survival challenge. That's one of the most ambitious engineering projects in the history of our species. And here's the goal that keeps everything on track. Roughly 1 million people need to be living and thriving on Mars before anything catastrophic happens on Earth. Because if Earth goes down before Mars is self-sufficient, it's game over for humanity, so the stakes couldn't be higher. Now, you might think, okay, just send people, brave people, tough people. But Mars doesn't care how tough you are. The surface temperature makes Antarctica look like a beach vacation. The dust storms make the Sahara look calm. The atmosphere is so thin that liquid can't even exist on the surface. There's not enough pressure to hold it together. Water just evaporates instantly. Gone. No puddles, no rivers, nothing. And humans are mostly water. Step outside without a pressurized suit, and you don't just suffocate. You freeze, you boil, and your lungs give out, all at the same time, within seconds. And if by some miracle you survived that, the radiation would get you. With almost no atmosphere, there's nothing standing between you and the sun. Just raw, unfiltered solar radiation baking the surface 24 hours a day. So sending humans out there unprepared isn't brave. It's just death. That's why the first residents of Mars aren't going to be human. Before any person sets foot on Mars, the planet will already be crawling with robots. Dozens, maybe hundreds. And the one leading the charge? Optimus, the Tesla bot. Now, it's probably not a coincidence that a sister company of SpaceX is building exactly the kind of robot they're going to need. Optimus is a fully autonomous, AI-powered humanoid. It's built to do any job a human can do, and on Mars, that's going to mean everything. SpaceX's current roadmap shows the first ships launching as early as 2026, 5 Starship landers, each carrying 10 tons of payload. The only goal of that first trip? Land at least one without crashing, because there's a learning curve. SpaceX knows it. They learn by failing fast and fixing faster. Stuff blows up. They study the wreck. They improve. They go again. That's the model. So assume one Starship touches down safely and opens its cargo bay. A handful of Optimus robots step out onto the Martian surface for the first time. The planet is silent, barren. Orange dust as far as the eye can see, and those robots get to work. 2 years later, the second wave arrives. This time it's not 5 ships, it's 20, each carrying 75 tons of cargo. Most of it is infrastructure, the bones of a future colony. But before we get into what they're building, we need to talk about where. SpaceX has already identified a target, the Arcadia Planitia region, a flat plain just northeast of Olympus Mons. And yes, that's the tallest mountain in the entire solar system, sitting right next door to the future first city on Mars. Arcadia is flat. It's close to the equator, which means reasonable temperatures and decent sunlight. And most importantly, it's believed to sit on top of massive underground deposits of water ice. Water ice is everything. Here's why. You can't bring enough water from Earth. It's too heavy. Even recycling every drop on the 8-month journey, turning urine back into drinking water, there's a hard limit to how far that gets you. But if you can find ice on Mars and process it, suddenly you have water, which means you have drinking water. You have oxygen, because you can split water into hydrogen and oxygen. And you have the foundation for rocket fuel. The Optimus robot's first priority is getting a water treatment plant up and running. Melt the ice, clean it, pipe it. That one facility unlocks water, breathable air, and the first step toward making fuel. Here's something most people don't think about. When the first human crews land on Mars, there's no fuel waiting for them to get back home. You can't carry enough for a round trip. The ship lands on fumes. So if humans are ever going to have the option to return, or even if unmanned ships need to keep shuttling between Earth and Mars, somebody has to make the fuel on Mars. SpaceX uses methane as fuel for Starship. And methane is just carbon and hydrogen. Hydrogen? It comes from water. Carbon? Comes from the air. The thin Martian atmosphere is mostly carbon dioxide. A carbon capture device pulls the carbon out, mixes it with hydrogen, and out comes methane, rocket fuel, made on Mars. The robots build this fuel plant too, before humans ever touch down. But none of this works without digging. The water ice is underground. You have to mine for it. And here's where another SpaceX-adjacent company steps in. The boring technology originally developed for tunneling under cities gets scaled down into a Martian mining rig. It digs. It extracts ice. It sends up rock and soil as a byproduct. And that's not a waste. That rock gets processed into asphalt for roads and landing pads. The colony is building its own infrastructure out of what it digs up. By around 2030, this is what Mars looks like. A small robotic outpost, paved surfaces, operating water and fuel plants, and a crew of Optimus bots waiting for the next wave. This is where it gets real. The third wave is massive. 100 Starship landers, each carrying 150 tons of cargo. The first human settlers are on board, and the moment they land, new projects have to begin immediately. Up until now, solar panels and small battery packs were enough to keep the robots running. Humans need a lot more. Life support systems don't sleep. Oxygen generation, water circulation, heating, pressurization, it all runs around the clock. Every 12 hours, Mars goes dark as the sun sets. Solar panels can't carry that load alone. But Tesla, surprise, surprise, has been building something called the Megapack. A massive battery storage unit. You can fit a couple inside a Starship. One Megapack can power a small town for hours. So keeping a small colony alive overnight, actually doable. Once the power plant is operational, all the infrastructure the robots spent years building finally switches on. The colony comes to life. For a while, the Starship landers themselves are the homes. They're massive ships. They have space. They provide pressure. They work fine short-term. But long-term, living in a tall, narrow rocket with an elevator isn't exactly comfortable. People need real homes. So now humans and robots work together to build permanent habitats. Everyone imagines a giant glass dome. Gleaming, sci-fi, beautiful. Let's talk about why that's not happening first. The closest thing to that on Earth is the Nature Dome at Singapore's Changi Airport. It covers 135,000 square meters. The structure alone weighs 3,500 tons. That's 350 Starship loads, just for one dome. Plus all the construction equipment to assemble it on the surface of Mars. Not happening. Not in the early days. So you think creatively. You use what Mars actually gives you. NASA's Langley Research Center has been studying this. You start with an inflatable donut-shaped module on the ground. Put a mold around it in the shape of a dome. Then robots fill it with water ice pulled from the surface. The ice freezes. Solid shell. Natural insulation. Built-in radiation shielding. Because here's something wild. Water is one of the best materials on Earth, or Mars, for blocking radiation. The same reason Inuit people built igloos to stay warm, the ice dome keeps deadly solar radiation out. And it's translucent. Natural light filters through, which matters more than you might think. Keeping the human sleep cycle intact and protecting mental health in a place that already has every reason to break you down. Ice domes work for housing, but you need factories, research labs, and larger structures too. For that, you need something more like concrete. A solid shell around those inflatable modules. And you can make it from the rock and soil the mining operation digs up. You just need a binder. Something to hold the rock together and harden it. That binder is going to come from the colonists themselves. This is called Biocrete, or Astrocrete. Researchers at the University of Manchester have actually tested it. The process uses human blood, sweat, and urine mixed with Martian soil to create a concrete stronger than anything we build with today. Medieval stonemasons mixed animal blood into their mortar when building castles. This isn't as new an idea as it sounds. And on Mars, where everything has to count, nothing goes to waste. Not even the stuff you flush. Water, oxygen, fuel, shelter, power, all solvable, hard, but solvable. Food is the one that might actually break you. Mars soil is toxic. Not just bad for growing, toxic. It's loaded with perchlorates, which contain chlorine, the same chemical we dump in swimming pools to stop bacteria growing. Plant anything in raw Martian soil, and it dies. So you have two options. One, ship soil from Earth. But a starship full of dirt doesn't go far when you're trying to feed 1 million people. Two, build an industrial soil processing operation on Mars. Strip out the perchlorates, supplement nutrients, manufacture farmable earth from scratch. Neither option is easy, both are necessary. And then comes the fertilizer question. If urine can make concrete, then you already know where this is going. Human waste can fertilize the fields. It's not glamorous. Nobody's going to put it on the brochure. But it closes the loop on a biological cycle that's been feeding human civilizations for thousands of years. Grow food, feed people, process waste, feed the soil, grow more food, self-sustaining. Let's zoom out. Power, water, oxygen, shelter, food. If a Mars colony can produce all 5 of those things without a single ship arriving from Earth, then humanity has done something that has never been done before in the history of our species. We've survived away from home. Not just survived, thrived. 1 million people, living and working on a planet that had no intention of letting us stay, and building something, a city, from nothing but ice, rock, robot labor, and human waste. The goal isn't just a colony. The goal is a backup drive for the human race. Because if something catastrophic happens on Earth, and history says something, eventually, there needs to be another branch of humanity that keeps going. That doesn't blink out with us. Mars is that branch. This isn't a dream project anymore. The robots are almost ready. The rockets are being built. The landing sites have been chosen. The first chapter of human life on another planet is being written right now, in engineering specs, in material science labs, in the field tests of an AI robot learning to walk. We're not waiting for the future anymore. The future is already boarding the ship.